Welcome to the another session in Frontiers in CFD. CFD simulation of liquid cooled thermal management system for cylindrical lithium-ion battery. So today's objective is to prepare the geometry of lithium-ion battery with liquid cooling, to generate the mesh element size and give the name selection so as to apply the boundary conditions in the setup part and visualize the result. Welcome you all for today's session. So this is the geometry that today we are going to prepare. At the same time we are going to do the analysis on this. So the first phase will be preparation of geometry and uh, proceeding for preparing the first as a geometry, and then we'll do the analysis. So first of all, open the workbench window. So on the left hand side we are observing the geometry, so that we are going to prepare first, and simultaneously we'll go with the second, which is on the right hand side. So to give the details of the geometry, there is a cells of 18 mm diameter and 65 mm height, and there is a casing around it that is a 20 diameter. Then the distance between the two cells are 23 in the vertical direction, and in horizontal it is 22. So they are not uniformly placed, they are placed in like a serpentine channel. So let's proceed with the fluid flow fluent option. Open with the geometry part. So let's go with the new design modular geometry. So as per the geometry which is available to us, so this is one of the thing which we are going to follow. So first of all, setting the units, I will set it to millimeter. Click on any one of the plane XY. We'll start the object with the help of first there are one thing which is either you can specify only the fluid zone, and you can specify the casing also, or if you want you can actually avoid the casing part also to reduce the complexity in order to reduce the number of nodes and element in a given cases. So likewise there are two approaches, as I said earlier. You can directly follow by considering the the fluid zone and the cells, and accordingly also the things can be proceeded. So the casing which is we are having, the outer casing which we are having is around 2 mm as a say 1 mm as a thickness over here. So 119.5, and this is the second outer portion is 121.5. So likewise we'll proceed for preparing the geometry, and we'll see how the things goes. Okay, so first of all I will just create the outer portion, that is this one 119.5. I am avoiding the outer casing because ultimately it will go on to add the number of nodes and elements. So for simplicity I am just avoiding the outer casing over here. So 119.5 is the dimension that we are going to follow. So let's create the geometry with the help of design modeler tool. So go here. So I will create a primitive. Units we are already saved, so instead of add metal, make it add to frozen. So if you go back to geometry, it is 118 by 119.5. So I will put it x coordinate 118. So let's put the x coordinate as 118. Then z y coordinate is 65. Z coordinate I will put as 119.5. Either you can prepare this in z direction as well as on x direction also. So I will put it 119.5 here. So 119.5. So this is a box like structure which has been there. So with this box like structure, this is the z component is 119. So this component is 119, and the x component is your 118. So likewise the things are there. So if I am going to specify the inlets and outlet, they will be somewhere here. So it will be based upon the z coordinates also, or if you want you can make the x component as 119.5 and z component as 118 also. So in that case what will happen, the uh, the inlet which you are specified here, it will be along the x direction, so depends. So I'm keeping this as it is, and let's make it generate. So this is how uh, the actual geometry with us as of now. Let's Okay, so this is how we are going to proceed. So 118 we are took, and this is 119.5 we are taken. So now the distance of one of the cell from one end, that is 15, which is specified here. So, and the same will be on the other side, that is 15. So let's first create this is 22 and 15. So we'll start from either this part or this part. Okay, so if somebody follows from this direction, this distance is 28.5. So similarly, this distance will also be equal to 28 point. Okay, so you can see 28.5, and this is your 15. So both this way also you can proceed. So 15 and 28.5 I will take. So create, let's say, primitive, that is cylinder. Instead of add metal, make it slice metal. X component I will now okay, first of all, radius I will define, that is 9 here. Now I want this to be in y direction, so I will make it z component to be equal to 0. So shift it. Now this is so I will put it 15, and this is the what I specified earlier, so that is 28.5. So let's take it 28.5 as a z component here. So 28.5. So this is how the placing will be. So let's make it generate. So one first we'll generate the cylinders of cells, and then we will generate the casing. So first the portion. Now the next is the distance between the two cells is 23 vertical distance. So let's take it 23. So one more time, let's create a primitive, that is cylinder. So instead of add metal, make it slice metal. So the radius is by default 9. Y component I will make it 65. Let's make equal to 0. The x component now will be equal to, so earlier we had 15, so this is also 15. Only the thing is z component will be 28.5 plus it will be 23. So let's see this one, 28.5 plus 23, so that is in the vertical direction. So that is will be 51.5. So carefully you have to take. Yeah, so this is the second point, which is the location we are having. Let's make it generate. So this is one second thing which has been uh, there. Okay, so let's one more thing, let's go to the primitive. I will put it cylinder. Instead of add metal, I will make it slice metal. X component I will put it 15 as it is. Now the z component will be plus 23, I will add, so that is 74.5. so this will be the third location. Y component make it 65, z component will be equal to 0. So let's make it generate. So this is the third thing which I have generated. One more time, let's go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be 15 as it is. The y component will be 65. Okay, y component of axis definition will be 65. Z component I will make it 0. This z component in origin definition now plus 23 of 74.5, plus I will put it 23. So this will go to 97.5. So this is the fourth cell which we are having. Let's make it generate. So this is how the first thing which is generated. Now similar to this, we have one more layer which is there, but the distance here is 22. So this was 28.5. Now the distance here is 22. So accordingly we'll proceed. So create one more time. You have to go with the primitive, that is cylinder. Instead of add metal, make it slice metal. X component we will take as, so now it is 15 plus the horizontal distance between the cells. So this is 22. So 15 plus 22, that is equal to 37. So x component now will be equal to 37. So z component here. So for the first case, as a which we observed, the distance is 22. So I will put the z component to be equal to 22. Let's put the y component as 65. Z component in axis definition will be equal to 0. So let's make it generate. So ensure that the everything operation which we have done are the slice operation. Okay, so next is one more time create primitive, that is cylinder. So make y component to be equal to 65, z component to be equal to 0. Now x component will be again 37 as it is the previous case. Only the thing this will change. Now earlier it was 22, now it will be 44 because the distance between the two cells are 22. So rest of the things I will, instead of add metal, I will make it slice metal and then generate. Okay, so in this way the second is also generated. So let's create primitive, that is cylinder, instead of add metal make it slice metal, x component. So the third position will be at 66. So put z component as 66, y component as 65, this z component will be equal to 0. So let's make it generate. So create one more time, go to the primitive, that is cylinder, instead of add metal make it slice metal, x component will be 37, this z component will be 88 now, and this is y component will be 65, and this z component will be equal to 0. So let's make it generate. So next one more time let's go to the create primitive, instead of add metal make it slice metal, x component now will be equal to 59, z component will be equal to first, so that is 28.5 as the first one which you have done. This y component to be equal to 65, this z component will be equal to 0. So let's make it and generate. So one more time let's go to the create primitive, instead of add metal make it slice metal, x component will be equal to 59 again, z component will be equal to 28 plus 0.5 plus 23, so that is 51.5. So go here, y component is 65, z component will be equal to 0, and let's make it generate. So one more time create primitive, that is cylinder, instead of add metal make it slice metal, the x component I will put as again 59, z component I will put at 74.5 here. So instead of add metal make it slice metal, y component will be 65, let's make the z component to be equal to 0 and generate. So one more time create primitive, that is cylinder, instead of add metal make it slice metal, x component will take it to be equal to 59, this z component will be equal to 97.5, y component will be equal to 65, let's make it 0 and generate. So this is how the next part has been prepared. Similarly we'll go to the fourth pattern, instead of add metal make it slice metal, let's x component to be equal to 81, z component to be equal to, so this is first is your 22, then y component to be equal to 65, z component to be equal to 0, let's make it generate. So one more time go to the primitive, let's say cylinder, instead of add metal make it slice metal, x component will be now 81, z component will be 44, this y component will be 65, and this will be equal to 0. So let's make it generate. One more time create primitive, that is cylinder, instead of add metal make it slice metal, x component will be equal to 81 again, z component will be 66, y component will be 65, and this will be equal to 0. So let's make it generate. One more time create primitive, that is cylinder, instead of add metal make it slice metal, x component will be equal to 81, z component will be 88, and this y component will be 65, and let's make the z component to be equal to 0. So let's make it generate. Okay, so the next is your the fifth one here. So that is equal to 103 distance. Okay, so let's create primitive, that is cylinder, instead of add metal make it slice metal, so x component I will put 103, z component will be 28.5, and then y component will be 65, z component will be equal to 0. So let's make it generate. So the last is 103 distance. So create primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be equal to now 103. Z component will be now 28.5 plus 23, that is 51.5. So this will be second component. Put y component to be equal to 65, z component to be equal to 0, and let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be equal to 103. This z component to be equal to 74.5 now. Y component will be 65, and this will be equal to 0. So let's make it generate. So last one, primitive, that is cylinder. Instead of add metal, make it slice metal. X component is 103. This is 97.5. This is 65, and let's make it 0 and then generate. So total we have generated around 20 cells. Now we will generate the casing for the same. So we note down the distances of each and every cell from vertical location, and accordingly we will proceed for the same. Okay, so let's one more time create primitive, that is cylinder. Instead of add metal, one more time I will make it slice metal. Now instead of 9 I will put it 10. Here x component will be first, that is 15, then z component will be 28.5. The same distances which we have took earlier for the cell, that we are going to follow, and rest of the things will be same. So let's make it generate. So create primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be now this is 15, z component will be equal to 51.5, then y component will be 65, this z component will be equal to 0. So let's make it generate. So next create primitive cylinder. Instead of add metal, make it slice metal. X component is 15 again, z component is 74.5, then the y component will be 65, this z component to be equal to 0, and let's make it generate. One more time create primitive, that is cylinder. Instead of add metal, make it slice metal. X component is 15, z component is now 97.5, this y component is 65, this z component to be equal to 0. So let's make it generate. So similarly we will generate casing on the other portions also. So create a primitive, that is cylinder. Instead of add metal, make it slice metal. X coordinate now will be equal to 15 plus 22, that is equal to 37, and the z component will be now 22. So y component will make it 65, z component will make it 0, and let's make it generate. So this is the second casing we are the second portion where we are doing casing. One more time create primitive, that is cylinder. Instead of add metal, make it slice metal. X component I will take it 37, z component I will make it 44, y component will be 65 again, and this will be equal to 0. So let's make it generate. Sorry, let's make it 44. Just check. No. So make it 44 here, and let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be now 37, so z component will be 66, this will be 65, this will again make to be equal to 0. So let's make it generate. So third layer we are generated. Go to the create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X coordinate will be equal to 37, then z coordinate will be equal to 66 now, sorry 88 now, then make it 65, and last one make it 0. So generate. So similarly create primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be equal to 59, z component will be 28.5, this y component will be 65, this will be equal to 0. So let's make it generate. Okay, so create go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be uh, 59, Z component will be 51.5, then this Y will be 65, this will be equal to 0. Let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be 59, Z component will be equal to 74.5, this Y component will be 65, and this one will be equal to 0. So let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be equal to 59, Z component will be equal to 97.5, then this Y will be 65, and this Z component will be equal to 0. So let's make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be equal to 81, Z component will be 22, this Y component will be 65. Let's make it 0 and generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be 81, then Z component will be 44, this will be equal to 65, this is 0 and make it generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component will be 81, Z component will be 66 now, then Y component will be 65, this will be equal to 0. So let's make it generate. Okay, let's go to the create primitive, that is cylinder. Instead of add metal, make it slice metal. X component is 81, Z component will be equal to 88, then Y component will be 65, this will be equal to 0. So let's make it generate. Okay, so the fourth has been done, so last is going for the fifth one. Create primitive. Instead of add metal, make it slice metal. X coordinate will be 103, Y coordinate will be 65, sorry, not 65, 0. Last one is 28.5, Z coordinate. Y component will be 65, this will be equal to 0, and let's make it generate. Create, say, primitive cylinder. Instead of add metal, make it slice metal. X component is 103, then Z component will be 51.5, then this Y component is 65, this Z component to be equal to 0. So let's make it generate. So create primitive, that is cylinder. Instead of add metal, make it slice metal. X component is equal to 103, then Z component will be equal to 74.5, then Y component is 65. Let's make the Z component to be equal to 0, and let's generate. So create, go to the primitive, that is cylinder. Instead of add metal, make it slice metal. X component is 103, Z component is now 97.5, then this is Y component is 65, this Z component to be equal to 0. So let's make it generate. So we have generated all the casings along with the cell. Now it's time to generate the separation which we have observed here. So this is a separation which is of 2 mm diameter. So sorry, not diameter, it is 2 mm thickness that we have to generate. So for this we must understand what is the distance to the center from left end, and then only will be in position to do this. So distance from the left end we know for the first, second, third and the remaining cells that we are aware of. So accordingly we will proceed for this particular we can say scenario. So total distance is 119.5, so that is also we need to take into consideration. So let's go back to the geometry. I will do this with the help of primitive. Let us say a box here. So what is my thickness? The thickness is 2 mm, so I will put X component as 2, Y component I will put 65. Now Z component we have to decide. So the thing is, as per the dimension which we are considering only fluid zone, so it will be 119.5. So make 119.5 here. Okay, now at what location we have to shift it? We have to shift it at a distance of, okay, so the distance is from one end to the center of the cell is 15. So we have 1 as or 2 mm as a thickness. So I will take the distance that is equal to 14 from the left end. So that is here 14 I will put, so that it will be exactly at the center. Instead of add metal, I will make it slice metal, and then I will generate. So X I took 14 here. Z nothing I have specified, only Z I have put 119.5, and let's make it generate. So this will be separation of we can say the portion where the fluid is likely to flow. So similarly we are going to generate it at the other locations. So create, go to the primitive, that is one more time box. Instead of add metal, make it slice metal. So the X component now will be for the second, the distance of the second cell was 37. So I will take it 36 here, and X component will be 2, the Y component will be 65, and your Z component will be 119.5 as it is. So this is we will generate one more time, so it will be separating out second part. So one more time, okay, not cylinder, I will delete this. So create, go to the primitive, that is a box. So instead of add metal, make it slice metal. X component I will put, that is equal to 58. Earlier it was 59, so I will take one less. So X component will be 2, Y component will be 65, and your Z component will be 119.5. So let's make it generate. Ensure that the things are done as a slice metal before proceeding. So ensure the second thing we have took 36, third one we have took 58. So create, go to the primitive, one more time a box. Instead of add metal, I will make it slice metal. X component now will be the third one was 81, sorry, yeah, the fourth one was 81, so I will took it, this is 80. So X component will be 20, Y component will be 65, then Z component will be again the 119.5. So let's make it generate. So in all cases we have done the slice operation. So one more time, create a box. Instead of add metal, make it slice metal. So last one is 103, I will take it 102. So this is 2, this will be your 65, and this is your 0. So let's make sorry, not 0, 119.5. So let's make it generate. So we have done all slice metal. We have to ensure that everywhere we have done the same slice metal operation or not, so that we have to carefully check before proceeding. So okay, so all these metals have been sliced. Now it's time to um, we have sliced this. So some of the portions we need to make as a unite. So I will select all this center part. Okay, I will select as a entire 3 things which are having, and I will make this unite so as to become a cell. Okay, so the last one. So go to the create, I will go with the boolean operation, make it unite. So the 60 bodies will be unite like a cell. So this is now your cells. Now it's time to go for the casing part. So this they are not going to unite, so I will make this as a form new part, which is for our separation. Okay, so ensure that everything is selected now. Okay, this one is left. Okay, ensure everything is selected. Now make form new part. Okay, so I will hide this part so as to select it in proper way. Okay, so I will hide all the remaining others also, so that it will be easy for us to proceed. Okay, so now I will select all and we'll go to the boolean operation so that the casings will be of uniform now. Okay, so now I will make it show all bodies. So this is cell, this is casing, and this is the separation which is in the channel. So we have formed that part. Again, you may select all the cylinders here. I selected all the cylinders. I will make is a form new part here. So I may define this as a cell. Okay, so this was your casing. So sorry, not this casing. I will say it is separation. Okay, separation in the channels. Then I will select the casings now. So 1 2 3 4 5. So carefully select all this thing. Okay, so I have selected all. So form new part also. So I will rename this as casing. Why we are doing this? Because to avoid the more boundary conditions later on. So that is only the thing we are doing. So this is second, third, fourth, and this is fifth. I will specify them as again form new part. So I will mention this as fluid zone. Okay, so this is separation, then cells, then casing, and this is your fluid zone. In addition, we required some inlets and outlet over there as per the geometry. So that was 8 by 10 as a boxes which we are there, but this was considering the casing, so I will have to add 8 plus 11, 8 plus instead of 10 I have to use 11 over here. So let's proceed. uh, yeah, or even if you can take add 8 by 10, that's also okay, but that will be on one side, so that we have to carefully do. Primitive, that is a box like structure. Now here, so your x component is your 8, not sorry, this not x, this x component, this x component is 8. This y component is, I will put it 65 as it is, and z component will be equal to the 10 I have put. Okay, so this is here. I will shift it in the other direction, so I may put this as minus 10, so it will be coming on other side here. So instead of add material, I will make it add to frozen and generate. So this is first which has been generated. So create, let's say primitive. One more time I will select the box. Instead of add material, I will make it add to frozen now. X component now will be, okay, first I will define this. X component is your 8, y component is 65, z component will be equal to now this is 10. I will keep it 10 as it is, only the distance which at which it is placed they are going to change. So this is minus 10 I will put because I want it on here side. So as per the uh, distance which we are having, the distance between these two is 22. Maybe somewhere it is mentioned. Let's check. No, sorry, distance between the two is 14. Okay, so this distance is 14 plus this is 8, so you have to shift it accordingly. So 14 plus 8 I will put directly as 22, so it will be at the center of this. So make it generate. So this is 22. So next is create one more time box. Instead of add metal, make it frozen. So 14 plus 8 we have took, that is 22. So every time we have to go add 14 over there. So x component is 8, y component is 65, z component will be 10, so I will put it minus 10 here. So x component, the distance I will put, so this is 36 I will put now. No, not 36, it will be 8 plus 14 plus 8 plus 14, so that will be 44. So make it add to frozen and generate. So create, go to the primitive, that not cylinder, create, go to the primitive, that is a box. Instead of add metal, make it frozen. X component is 8, y component is 65, z component is equal to 10. I will put it minus 10 to have it on the other side. The x coordinate which is to be there, now it will be plus 8 plus 14. So I'll put it 66. So let's make it generate. Create one more time. Instead of okay, so instead of add metal, make it frozen. X component will be now 66 plus 8, that is 74 plus 14, 88. So 88, this x component is 8, y component is 65, z component to be equal to 10 minus 10. Let's make it generate. So create, go to the primitive box, instead of add metal, make it add to frozen. X component is 8, y component is 65, then z component is minus 10. So x component will be 110. Let's make it generate. So we have done it for the top side. Similarly, we have to do it from the bottom side. So the distance will be changed now. The total distance is 119.5 as per what we, yeah, as 119.5. So accordingly, we'll do it on the other side. So create the primitive, say boxes. X component, I will put it 119.5. Sorry, let's pick it. X is, this is 65. Z will be equal to 10. Let's make it 0 first. Okay, so here it is here. Not x component, here I require z component 119.5. So let's make it generate. So make it add to frozen, generate. Create one more time. Box, instead of add metal, make it add to frozen. X component is 8, z component is 10, this is your 65. Then here the first distance is so this is 8 plus 14, that is equal to 22. So I'll put it distance x coordinate, sorry, not x coordinate as 22 first, and z coordinate as 119.5. Okay, so this is 22, then 44, 66, and so on. So create, go to the primitive, that is a box. Instead of add metal, make it frozen. So x component is 8, y component is 65, z component is equal to 10. X component now will be equal to 44, and z component is 119.5. So let's make it generate. Create one more time, primitive box. Instead of add metal, make it add to frozen. X component is 66, then 119.5. This x component is 8, y component is 65, and this is equal to 10. So let's make it generate. So create, go to the primitive, that is a box. Instead of add metal, make it add to frozen. X component is equal to 88, then y component is 119.5, this is equal to 8, this is equal to 65, and this is equal to 10. So let's make it generate. So create one more time primitive as a box. Instead of add metal, I make it add to frozen. The distance is now 110, and this is 119.5. This is your 65. This will be equal to 8, and this is your 10. So let's make it generate. So we have generated all inlets to the portions, and now we will proceed. So this zone and this zones I will go on to unite, because this is a part of same thing. This is acting as inlet for us. Okay, so go to the create and make it boolean, unite, generate. So this is the one section, this is the second section, third, fourth, fifth, and this is last one, sixth. Okay, so one more thing which is might have been okay. So this is your fluid zone, this is your casing, this is your cells, and this is your separation. So one more thing which we required is to do some manual work here. Separation, we need to define all them are separation. Cells, we need to define all of them are cells, otherwise there are conflicts in the boundary condition later on, or to it will be difficult to understand which part is in which. So that's why it is important now to give the names also. So for each and everything which is we are having, so make it give the name here. So this is a task which has to be done. Purposefully I'm keeping the uniform names, otherwise there are chances of you can have 1 2 3 and also. So if you select all and specify the name, it may show you 1 2 3 4, but purposefully I'm avoiding this. Last one is your this one. Now let's go with the casing part here. Next is your this one, casing. This is solid, here we have casing. This one is also your casing. So we have done it all for casing. Lastly is fluid zone. This is the one which we need to make. So let's make it control V. So let's make it control V. So let's make it Control V. Okay, so what I will do here, I will make all of them as fluid now, and let's make it generate. So all of them will be fluid zone, fluid zone, fluid zone, fluid zone, fluid zone, and so on. Now the part with the geometry is actually been over, so we'll see the subsequent parts now. So this is your, okay, so casing also, separation we also specified the name, cells we also specified the name. So likewise separation, casing, cell, and fluid zone. So this is what done. Now it's time to proceed for the mesh part. So the next step after generating the geometry is to proceed for the mesh. So let's click on the mesh part, click on edit. So we'll try to generate a comparatively finer size of mesh. Right click, generate default mesh first. Not look to be of acceptable quality, so I will just go into with comparatively finer size of mesh. Right now it is 74,310. So I will just change the element size to let us say 0.00. So the required size of mesh right now it is a quite higher number of nodes and element. So this is the required mesh we have generated. Looks to be better, but still it can be made finer than this. So if really want, you can go with 0.0005 also, but again the time requirement will be more in such situation. So let's make it generate and we'll see how much time will be required. But if you say 0.0005, the time required for simulation will also increase, and the time required for generation of mesh will also be more. So the mesh size is very fine, so it will take some very long time in order to generate the results, and that's why we'll go back to the previous one, that is 0.001, and we'll generate the mesh. So the mesh generation has done. Now we'll specify the name selection on this domain. So as to that, we'll apply the inlet and outlet over here. So we'll specify this one as the outlet, or let's say this is inlet and this will be outlet. So both of way it can be done. So like if I want this as outlet, I will put it here, name selection, make it outlet here, and on this side will, from the origin I will put this as an inlet. So let's make this as the inlet. So next is inlet. Here we have specified outlet and inlet. Apart from that, we can specify the convection on the outer surface which is available for the cell. So if it is required, we can put the cell convection convective heat transfer coefficient over there. So let's for this I will select the casing and hide all other bodies. So I will select all the faces of the casing, and on that facing I will specify the convective heat transfer coefficient. So we will be specifying this in the boundary conditions, but as of now we'll just specify the name selection here as a casing convection. So here I will just specify the casing convection, make it okay, and let's make it okay. First of all, show all bodies, and let's make it update. So once this is updated, you will see the mesh translation to Fluent successful option. If the mesh translation, yeah, this one, mesh translation to Fluent is successful. Once this is done, you can close this window and you can proceed for the next part. So let's say close the meshing. So geometry is also not required. I will just close the meshing. So just ensure that fluid zone whichever we have specified, it is uh, so in definition it is already fluid. So that is one thing we have to ensure before proceeding. So we don't require the design modeler right now. So I will close the window. Now next part is go to the setup. So select the number of processes your computer can run. So I will select it 16, make it double precision, and let's proceed further. So now we are opening the setup part. So we need to specify the gravity first. It will slightly take time to our loading. While preparing the geometry, you can provide the whatever the separation is there. On that separation also we can provide some kind of convection over there. Okay, so this is inlet and outlet we are having. So I will select the transient model option available. So once the loading is over, we'll select the transient option. So transient, then specify the gravity. Let us say it is minus 9.81 here. Go to the model. Energy equation I will make it on. We are not involved in multi-phase fluid flow, so I am not going to change it. Go to the viscous. I will select K epsilon, enhance wall treatment, thermal effect and curvature correction. So this is what I have selected. Now next thing, there is no solidification and melting, so I will not select that option. So go to the materials. So fluid, I will select water liquid as of the fluid which is flowing. You can select any other fluid whichever as per the scope of the project. So close this, close this. So next in solid I will put aluminum as it is, but instead of one more thing which I will add, so lithium battery. So here I will put lithium battery, and then I will specify the properties of lithium. So 2750, then 1250, and this is K. I will put it 0.1. So let's make it change create and make it OK. So this is what lithium I have specified. Then close the part. Then again solid. I require aluminum, so I will go to the solid part and select the aluminum. So make it copy and then close. So there are three different materials for us. One, it is the cell, then there is a casing. So casing and separation we are both considering as aluminum, so I am not going to make any major changes in the material part. Okay, so next is your zone type. So fluid zone, the here I will select the fluid which has been present. So we have selected, let us suppose, water. So I will select water liquid, make it apply over here and then close. Then casing. In casing you have to select the material. So aluminum, so make it apply and then close. Okay, so this is lithium battery. I need to select the source sorry, not select, it is aluminum. We have to select, make it apply and then close. So casing is aluminum. Then cell, we have to select lithium battery. So lithium, it is by default option is available. So I will click on source term, and I will select here the one, and I will put some heat generation per unit volume over here. So I will put slightly on the higher value, 289,855. This is a value which I am putting, watt per meter cube. So make it apply here and then close. So in separation I will select material, again aluminum. So make it apply and then close. So let's click here so as to visualize this part. Then boundary conditions, I will specify something at inlet. So that is inlet velocity we are going to specify. So inlet velocity I will put it, let us say, around 0.25 meter per second. You can select a different value also, or we can provide the mass flow rate also. So here I will just go to the bottom part, wall casing which you are having. So here on the wall casing I will like to prepare some convection value. This is 2 watt per meter square. Wall casing is made up of aluminum, so select that here, make it close. Wall cell, again define the we can say material which we are having. So wall cell I will put it lithium battery here, make it apply. No other changes I am doing. Then wall fluid zone, we don't need to do anything because we are not specified any kind of metal, so I'm not going to specify there. By default the casing, if it is been there for the battery pack, then in that case we can use that option. Wall separation, I will select this as again as aluminum, so make it apply and then close. So this is how the various things which we have covered. I will go to the casing convection. I will put the value, that is again 2 watt per meter square. So it is convection, I will put it as 2. Instead of lithium battery I will put it aluminum, make it apply then close. So wherever you are observing this casing convection, I will try to specify the value of convective heat transfer coefficient there. So let's say 2 here. Instead of lithium battery I will put it the material which is for your casing, make it apply then close. So all the option you have to select. Convection I will put it 2. Instead of lithium battery, make it aluminum, make it apply and then close. So make it apply here also, make it apply this one. So wherever the convection is been applicable, so that every location you have to check it and apply it. So make it apply, close. So depending on how many casings we have, accordingly the things will go on to increase. So here 2, then aluminum, make it apply, then close, make it apply, close. Then casing convection, go here inside convection, I will put it 2, aluminum, make it apply, then close, make it apply, close. So everything we have to select. So the last boundary condition, that is to make it aluminum, make it apply and then close. So this is for, we have done it for all. Now boundary condition also we have specified. Now it's go time to go for the report definitions. So wherever we want the reports, so area weighted average, I may want the total temperature at the outlet. So I will select the total temperature, and where I want at the outlet. So I will select the outlet option. So the total temperature at outlet we are having. So let's make it okay. Then one more time, surface report area weighted average. Instead of pressure, now I will take it total temperature of whole system. I will put it print to console output parameter. I will put it system, make it okay. Then one more time, surface report area weighted average. So if you want some static and other temperature, you can put it. Otherwise, if you want some other parameters also, so that can also be available here. So I'm not going to use any other thing apart from this. So total temperature at outlet and the temperature of the system we are specified. If you want the total temperature of cell, you can actually consider. But before that, I will just go to the initialization. Click on standard initialization, make it okay. Once it is initialized, the patch option will be available. We are not dealing with any kind of multi-phase fluid flow, so that's why we don't need much to do the patching. So autosave, maybe you can set it to around 20 time steps. Go to the solution animation. So first of all, go to the contours. Instead of pressure, I will take temperature. Then I will take, say, total temperature of the system. I'll put it here. So instead of exponential, make it float, make it apply and then close. Then save display. Once this is done, click on close option available here. Okay, so let's click on close. Instead of animation 1, I will put here as total temperature of, let us say, system. So this is one thing which I am doing. Okay, sorry, something is not selected. Contour 1, select over here, total temperature of system. Okay, make it close. Then contour 1, here I will put total temperature of SYS temp. So make it okay. Now one more time, go to the system. Instead of contours total temperature of the system, I will go with the cells. So here all cell, just make it display. So respective section also I need to consider. I will be interested in more about the temperatures of the cell. So I need to identify which are the contact regions available. So here, okay, so let's see this one. Contact region TRG. So I will select all of them as TRG regions. This one, this one, this one, this one. So some of the things we have to avoid it, this over there. So let's check it one more time. Some things may not be part of the go back and okay, so this is right now it is cells are available, so 90, so it should not be there. 89, so that is also coming, it should not be there. 87 trg, okay, that is also not required. 86 trg, okay, so that is also not required. 84, so also it is not the one thing which we required. 83, not the run. Select 14, okay, this is also not part of it. Say 15 trg, this is also not there. So individual cells portion we have to select, so we'll first go through it. So this is all casing convection, so let us say 10, what is there, no, this is not there. 100 trg is not there. Okay, 100 trg I select, so this has become 101 trg, so then 102 trg, okay, 103 trg, then 104 trg, then 105 trg, then 106 trg, then 107 trg, then 108 trg, 109 trg, and last one 110 trg. Okay, so all such cells have been there as of now. So make it save display, click on close. Now here I will put total temperature of cells. Make it okay. Then go to the run calculation. Select the number of steps here. I will put it initially for 10 just to check whether we are on the right way or not. So let's take it on one side. Here, click on calculate. So if everything is on the right direction, you will see the heating which has been taking place. Okay, so we forget to put this as a float scale. This is right now as exponential. I need to change it. So once the first 10 iterations are done, we'll change that. So one more time we might need to initialize this. So always check the usage when you are running. So till the time it doesn't complete the first iteration, the windows will not show, animation windows will not be shown. So we have to wait for some time. So we can see the changes in the color contours which are there. Along with that, we are able to see the variations in the temperature also, how they are taking place. So depending on how the fluid is flowing from inlet to outlet, we might see some variation in the forms of delta temperature at outlets also. So this is the temperature of cell. We might need to change the this scale to exponential one. This is the graph which shows the total temperature of the system, and this shows the total temperature at the outlet. Again, we have 5 different outlets, so you can specify 5 different things for outlet also, but that change you have to do in meshing part. For some time in order to complete the first 10 time steps, and then accordingly we'll visualize the things. So the simulation has been performed for some long time. You can just visualize the total temperature. Then this is the curve which we are having. So it has to be run further in order to visualize the total temperature of cell along with the total temperature of system. So we'll run this for further and then we'll visualize how the results are there at the end. So the simulation is completed here. We'll just check it out how the curves are there. So the temperature curve always becomes flat. So we can proceed with this now. Uh, Go to the result part. Let's click on edit. Let's go to the animation over here. So here animation, you have click on playback. So till that time we have generated it around 200, so we can just visualize this with the help of this one time frame. You may be in position to visualize this, how the variations are taking place. So temperature animation, you can see, you can save the video file also. Instead of selecting animation period, you can select the video option. Okay, let's open the post processor part. Here we'll see how the cell temperatures are there and along with the total temperature of the system. This might take some time to load. So I will click on the pause button here. So increment you can put it 10, let us say, and we'll check it how the things are happening. So this is first. You can see how the variations are taking place, how the temperature variations are there. Okay, let's open the post processor. Okay, so this is the post processor we have. Now we'll see the things slightly change. I will make, instead of the volume rendering, that is temperature, I will select the cells. Here I will select the cells and make it okay. So once you click on cell, a new geometry will be there, which is in terms of only cells. Okay, so these are the curves. So let's save the curves. This is total temperature system. So this is one image which we can share. This is also one image we can save. So go here, I will put it cell. Okay, so now let's open the post processor. So this is how the portion that is going to be visible. So you can save the files.